Java developers love using JUnit. But why? In this video, we're going to talk about 3 reasons why Java devs love JUnit. And we're going to talk about how to build a unified workflow for security and functional testing using JUnit. I'm Josh Grant, Developer Relations Advocate at Code Intelligence. Let's go. 3 reasons why Java devs love JUnit. First, it's easy to use. JUnit has a straightforward API that's easy to learn and easy to understand, whatever your comfort with Java is. 2, it's fast. JUnit tests run quickly and provide feedback and information around how your test is failing and specifically where things are failing, giving you the information you need as a Java developer exactly when you need it. 3, it's reliable. JUnit provides a framework and all sorts of utilities for writing all sorts of tests and getting test results back that you can trust to help make your tests and make your code as the best it can possibly be. So, what is JUnit used for? In addition to unit testing, which is testing specific units in certain classes or certain pieces of code that are under test, JUnit can also be used to write all sorts of other test automation, including API tests with various tools. It can be used to write browser tests and end-to-end tests where you drive your entire application in a real environment, such as a browser or mobile application. You can use JUnit to write performance tests and analyze the front end, back end, or any old end of whatever your application is doing from a performance perspective. And last and not least, you can also use JUnit to write security-based tests. So, how could you do this? Can you use Java and JUnit to write security tests? And the answer is yes. One approach for securing your code is to use fuzz tests. Fuzz tests are a great way to introduce fuzzy inputs into code under test, such as a method or function you want to test, or other pieces of software that you want to test. These fuzzy inputs can produce security vulnerabilities or help you to track down those hard to find bugs that you might not be able to find using functional tests alone. This allows developers and more to shift left. So what does this mean? This means instead of just thinking of writing your code and passing it off to an ops individual or a security engineer or a test engineer, Java developers can start thinking of test automation, security, and even infrastructure more and more as they write their code. This all sounds really great. So let's get started and look at an example of how we can create a unit test and use that to create a fuzz test. Let's go. Let's take a look at how we can create a functional unit test in JUnit and then use that functional unit test to create a fuzz test also in JUnit. Here, I have a class from an example project called Information Database. In this class, there are a few members and a few methods, but there's only one thing I want to focus on, which is this method, insert road data. It's a public method, and I'd like to test it. As input, it takes a road class, which is a model from another part of the project, and returns a Boolean. I'm not really interested in the details of this class or how things are implemented. I care about testing this method and verifying that if I insert a valid road, I will get a true value back. So how would I create a unit test for this? Let's start by creating a new unit test class under source test, and I'll call it information database test. In this class, I'm going to create an information database object, which I will use for testing. And I'm going to write a single test method using the test annotation provided by JUnit. Insert road unit test. Okay. So I run this test. This test runs, it passes. Of course it passes, it doesn't do anything. All I've done is create something that JUnit recognizes using a public method and using the @test annotation. In the interest of time and clarity, I'm going to walk through how I would actually create such a test using previously committed work. So I'm going to open up my terminal. First question I might ask is, how am I going to create a test? What's a strategy for writing a good unit test? So let's see what I can do. The first idea is to use the arrange, act, assert pattern. So this is where you construct a unit test that has 3 steps, very roughly speaking. Arrange objects and test fixtures that are for use. Then you perform an action, or you act on an object to test or verify certain behavior. And then you perform an assertion, and you assert that the result of this action under test is as expected. This is a common pattern and a very good pattern for thinking about how to write any kind of automated tests, but in particular, how to write unit tests. So with this in mind, let's see what kind of test I might be able to write following this strategy. So here, I've filled in some of the details of how I would test this method using the arrange, act, assert pattern. So first, I arrange objects and test fixtures. I need to initialize my database, which I've done here. And to help with this, I've created a utility method, initialize database, which performs some database initialization steps. I also need to create a road object. So this is a class representing, or this is an object representing a road, which we're going to use in the sample project. The road needs a constructor, and so the constructor requires a string to be passed in. Here, I'm passing in a valid fixed string. This is going to become important later. I'm just going to set this as a country, which is Germany. So that's my arrange steps. Now I need to have an action step or steps. So I'm going to actually call the value that I want to test, insert road data with the valid road, thinking that I want to verify that this will be a true value. So finally, I perform an assertion statement, assert true, and I verify that result is true. And if I run this test, the test runs and it passes. I have validated at least that this case works for my test. The only note I can make is that it's possible that I could turn this utility method into a before method using the @before annotation in JUnit. I'll leave that as an exercise for the reader, but that's something that you can do to help test reuse as well. So now that I have my unit test, how can I use this to create a fuzz test? Let's think about the simplest possible thing that could work. Some wise words, some from very wise developers. The first step is I'm just going to copy paste this test. And since Java requires unique method names in a given class, I'm going to call it this. Now, I'm going to use a fuzzer in order to generate fuzzy data to fuzz this method. What does that mean? Well, remember how I set this to a fixed valid string? What I want to do is I want to use this road value, but let my fuzzer generate fuzzy inputs or fuzzy values for this road value or this road class in order to test insert road data using a fuzzer. So what would that look like? If I use CI fuzz, which I'm able to, it would look something like this. I'm going to give a new annotation at fuzz test instead of at test. This is provided by the Code Intelligence Jazzer Java library, which is how I'm going to use my fuzzer, and that's sort of the fuzzer that I'm going to use. I need a fuzz data provider object, which I'm going to pass right in. So this now makes this data object something available to the whole class. And I'm going to replace, this is the crucial bit, I'm going to replace my fixed valid value with a fuzzed value. So here, instead of choosing a fixed value, I'm going to let my fuzzer automatically generate fuzzy values in order to test. And that's it. Notice here in my unit test, my functional unit test, I have a fixed value that's constant and valid. And in my fuzzy test, my fuzz test, I have automatically generated fuzzy values provided by the fuzzer. Now, let's run this test. I'm going to run this test using the command line, and I've already pre-configured my fuzzer to work via command line. So this is CI Fuzz, the CI Fuzz CLI. You can find more information at codeintelligence.com. And I'm going to run since I'm using Maven, the fuzzer first builds the project using standard Maven functionality. And now I've run, and look, it found a SQL injection. So this fuzzer has already found an issue in my insert row data method. It's possible that I can set up a SQL injection using certain data, certain malicious data or something, but my fuzzer's already found an issue. And that's all, and that's from starting with a valid unit test, which you may have already in your project, or as we've seen, is very straightforward to write. And not just based on this unit test, but also directly copied from. So it's very, very similar, and it's very simple to create even a simple unit test, which can find potentially highly problematic or malicious vulnerabilities in your code. You could also find bugs such as null pointer exceptions, stack overflows, these sorts of things, all in your Java code. And so that shows how to create a fuzz test from a basic JUnit unit test.